Hello, everyone. Hope you're doing all well. Uh, First of all, I'm so honored to stand before you today to discuss the existing topic of enhancing human-machine interaction, HMI, through multimodal interface with a specific focus on a user-centric approach. As we all know, today, our presentation will focus on the theoretical part of HMI. And today I'll be going through the introduction section. So I'll give you a brief introduction about HMI. Then I'll hop into traditional human-machine interface and their limitation, definition, and overview of multimodal interface, speech, touch-based, gesture, and user-centric design approach for multimodal interface. Then I'll hop into advantage of multimodal interface, future prospects of multimodal interface, and I will be ending up with the conclusion. So allow me today, to have a short introduction. So as we all know, human-object interaction, which refers to the study and understanding of how humans interact with objects in their environment. So we're very familiar with this topic, but traditionally, human-machine interface have heavily relied on visual and auditory inputs. As we all know, such as an example of that would be your keyboards, your mics, your monitors. While these interfaces have served us well in the past, they often fall short in delivering intuitive and natural interaction experience, which combine multiple moods of input and output, including speech, touch, gesture, and haptics. By harnessing the power of these multimodalities and placing the user at the center of the design process, we can revolutionize the way humans interact with machines. Traditional human-machine interfaces, with their heavy reliance on visual and auditory inputs, as we spoke earlier, keyboards, mics, monitors have been the cornerstone of our interaction with machines for decades. These interfaces have undoubtedly played a vital role in enabling technological advancement and fostering human productivity. However, they often lack the natural and intuitive interaction experience that we encounter in our everyday lives. HMI, or human-machine interactions, plays a crucial role in enabling seamless communication and collaboration between humans and machines. However, as technology advances, there's a growing recognition of the need of more intuitive and natural interaction modalities. This has led to the development of multimodal interface that combines multiple modes of input and output, such as speech, touch, gesture, and haptics, which I will be going through thoroughly in our presentation today. I will explore the concept of enhancing HMI through multimodal interface from a user-centric perspective. This is where multimodal interface comes into the picture. Multimodal interface leverage the power of multiple modes of input and output, such as speech, touch, and gesture, to create more intuitive user experience, if we can say that. By combining these modalities, we can tap into the natural way humans communicate and interact with the world around us. So basically, we will be going through different different HMI ways of interacting. The whole thing refers, like when we say human object interaction, it refers to the ways in which humans interact with and manipulate objects in their environment. It encompasses a wide range of activities and behavior, from simple actions like picking up and moving objects to complex tasks such as using tools, assembling items, or operating machinery. Human object interaction plays a fundamental role in our daily lives and is essential for completing various tasks and achieving goals. It involves the coordination of sensory perception, motor control, and cognitive processes to interact with objects effectively. Some key aspects of human object interaction obviously are grasping and manipulating. Humans have the ability, obviously, to grasp and manipulate objects using their hands and fingers. As we all know, you can manipulate, change things by using your hands and finger. This involves precise control of grip force. So we use our hand as a grip, our finger movement, and hand-eye coordination. So we use both sense, our eyes, our sight, and our feeling, our touch, in order to shape and manipulate some of the objects. We might use tool use. Humans frequently use tools to extend their capabilities and interact with objects in more complex ways. Tools obviously use involves understanding the properties of the tool, its purpose, and how to effectively apply it to manipulate objects. And we can see this so frequently in the mechanic shops. Object recognition. Before interacting with any objects, humans need to perceive and recognize it. Object recognition involves the ability to identify the object based on their visual features, such as obviously shape, color, or texture. Again, one more thing is object affordance. Affordance refers to the perceived possibilities for action that an object offers. For example, a chair offers sitting, a doorknob offers turning, and a pen offers writing. Humans are adept at perceiving and exploring these affordance to interact with the objects appropriately. Problem solving. Human object interaction often requires problem solving skills. When faced with a novel or a challenging task, the humans can apply their knowledge, reasoning abilities, and previous experience to find solution and achieve their goals. And the last thing of the key aspects of human object interaction, obviously, it's the cultural and social context. Now, human object interaction is influenced by cultural and social factors. Different cultures may have unique practices or norms related to how objects are used or interacted with. Social interactions involving objects can also be important, such as collaborative tasks or sharing resources. The study of human object interaction, it is of interest to various fields, including cognitive science, psychology, robotics, human-computer interaction. Understanding how humans interact with objects can inform the design of user-friendly tools, interfaces, and environments, as well as contribute to the development of intelligent systems that can interact with objects in a more human-like manner. Now, these are some of the examples of visual elements related to human-machine interaction. Obviously, these elements can enhance the user experience, facilitate communication, and provide intuitive interaction. Now, I can give you some examples of visual elements commonly used in human-machine interaction, which I do believe most of you today will be familiar with. Now, the most important one of the most important elements related to human-machine interaction, which we use on a daily basis, is the user interface, UI design. The design of the user interface plays a crucial role in human-machine interaction. Engaging visual elements such as icons, buttons, menus, and graphical controls can make the interface more visually appealing, intuitive, and easy to navigate. Effective use of color and layout can also enhance the overall user experience. Another really important element related to HMI is the feedback and response indicators. Visual feedback is essential in human-machine interaction to provide user with information about the system state, actions, and responses. This can be achieved through visual indicators such as progress bars, loading animations, success or error messages, and interactive elements that change appearance when activated. Again, AR, augmented reality, and VR, virtual reality. AR and VR technologies provide experience in human-machine interaction. Engaging visual elements in these environments can include realistic 3D objects. And the first example that jumps to my head, if you ever played the Pokemon game, that's an AR, an augmented reality. Interactive virtual menus, visual cues or guides, and dynamic visual effects, and respond to user action or system feedback. Again, we do have more like gestural interface, data visualization, but let me go to animated interface. Animation can be used to add dynamic and interactivity to human-machine interfaces. Engaging animated elements such as transitions, hovers, effects, or interactive micro interactions can make the interface more visually appealing, guide the user attention, and provide visual feedback on interaction. And these 6 or 7 points that I mentioned are all elements or visual elements related to human-machine interaction that can obviously enhance the user experience. Before moving to slide number 2, I really need to mention here, it is really important to note that while engaging visual elements and it can enhance human-machine interaction, they should be designed with usability, accessibility, and user-centered principle in mind. The visuals should support the functionality and goals of the interaction and not overlay or confuse the user. Traditional human object interaction. Obviously, visual and auditory inputs are fundamental components of human-machine interaction. And some of the example of common devices and technologies that provides visuals and auditory inputs in a human-machine interaction. Now, let's start with the inputs. Visual inputs, obviously, on a day-to-day use, we use the keyboard. Keyboard provides a visual input method for users to input alphanumeric characters, symbols, commands, and so on and so forth. Mic and trackpads. Mics and trackpads offer visual inputs through movement of the cursor, through voice on the screen. User can manipulate the mouse or trackpad to control the position of the cursor, perform selection, and interact with a graphical user interface, as we all experience on a day-to-day basis. Monitors and display presents visual output from computers and other devices. Touch screen allows users to provide visual input by directly touching the display. And graphic tables are input devices that allows users to draw or input graphics directly onto a flat surface using a style or a digital pen. They provide more precise and natural way to create visual content compared to traditional mouse-based input, as we all are familiar with. Auditory inputs, obviously microphones capture auditory inputs by converting sound waves into electrical signals. They enable users to input voice commands, participate in voice or video calls. What else? Or interact with voice-based virtual assistants. Speakers and headphones provide auditory output from computers and other devices, allows user to listen to sound effects, music, spoken instruction, and other forms of audio content. Voice recognition. Voice recognition system analyzes the interprets spoken words of commands or auditory inputs. They convert speech into text or trigger specific action based on the recognition of the voice command, enabling hand-free interaction with devices. And an example of today's TV sets, they're all they all use the feature of voice recognition system. Sound alert and notification. Device often use sound alerts and notification to provide feedback to alert users of event or change. Sonar and ecosystem is another example of auditory. Sonars and ecosystem commonly used in navigation or object detection application provide auditory feedback based on imitated sound waves and their reflection. The combination of visual and auditory inputs in a human-machine interaction allows for more comprehensive and multidisciplinary experience. These inputs facilitate communication, information processing, and control, enabling user to interact effectively with machines and technology. Basically, in this slide, we can say the need for more intuitive and natural interaction experience arises from the desire to bridge the gap between humans and machine, making technology more accessible, more user-friendly, and efficient. Some key reasons why intuitive and natural interaction experience is important. Well, obviously, as we all know, we need in our world today, we need to enhance user experience. Intuitive and natural interaction contributes to the positive user experience by reducing cognitive load and making technology easier to understand and use. When user can interact with machines in a way they feel familiar and intuitive, it leads to a smoother and more enjoyable experience. Increased efficiency and productivity. Intuitive interaction can improve efficiency and productivity by reducing the learning curve associated with new technology. When user can quickly grasp how to interact with a system or a device, they can focus more on the task at hand and achieve their goals more effectively. Again, I can go through so many, but due to time, let's just go to two more. Reduce errors and frustration. Now, we know complex or non-intuitive interaction can lead to user errors and frustration. By designing interfaces that aligns with users' expectations and mental models, the likelihood of errors is reduced, leading to a smooth and error-free experience. Adoption of new technology. Intuitive and natural interaction can accelerate the adoption of new technology. When users find it easy to interact with and understand a new device or system, they are more likely to embrace and adopt it, leading to faster technology adoption rates. The last example that crossed my mind just now, human-centered design. Intuitive and natural interaction experience put the focus on humans, their needs, their abilities. By designing technology with a human-centered approach, we create systems that are tailored to human cognition, behavior, and preferences, resulting in more effective and satisfying interaction. Overall, the need for more intuitive and natural interaction experience stems from the goal of making technology more user-centric, enabling seamless and effortless interaction, and empowering a user to leverage technology to its full potential. By bridging the gap between humans and machine, we can create a harmonious and productive relationship that enhance our lives and our capabilities. As we spoke earlier, multiple modes of input and output are combined in human-machine interaction to create richer and more interaction experience. The combination allows users to engage with technology using different modalities and enable more natural and intuitive interaction. Here's an explanation of how multiple modes of input and output are combined. When we talk about input modularity integration, multiple modes of input such as touch, voice, gesture, and physical controllers can be integrated to provide user with a choice of how to interact with a system or a device. For example, a touchscreen interface can accept both touch gesture and voice command, allowing user to choose the input modularity that suits their preference or the context of use. Multimodal feedback. Feedback from the system can be provided through multiple modulists to enhance the user experience and ensure effective communication. Visual feedback can include change in interface animation or progress indicators. Auditory feedback can involve sound, tones, or speech syntax. Feedback can provide such a vibration or a forced feedback. Combine these modularities creates a more comprehensive and intuitive feedback loop between the user and a machine. And I can go through a different number of integration between the model. A quick example is a cross-model mapping, multimodal data presentation. And let me emphasize a bit on this. Multiple modes of output can be used to present information to the user in a more accessible and understandable way. Visual data presentation can include graphs, charts, and icons, while auditory output can involve speech, synthesis, or audio cues. By presenting information through multiple modalities, user can choose the mode that best suits their preferences or accommodate their sensory ability. And again, we do have so many like examples, but at the end, let me summarize this slide. By combining multiple modes of input and output, human-machine interactions become more flexible, inclusive, and adaptable to individual user preferences and abilities. It allows for more natural and intuitive interaction, making technology more accessible, engaging, and effective in supporting human tasks and goals. Now, visual representation of different modularities of human-machine interaction, the first one and the most important one, or one of the most important one, obviously speech modularity. When we say speech modularity, it's the interaction through spoken language and voice commands. A visual representation, an icon or representation of a microphone or a sound wave emanates from a user's mouth. Touch, gesture, and haptics modularities, these are all important to note that these visual representation are simplified and symbolic representation of the modularities. In reality, each modularity involves complex processes and technology to facilitate the interaction between humans and machine. The visual representation serves as a way to visually depict and differentiate the different modulists in a simplified manner. As we can see in slide number 6, speech as a modularity. Now, when we say about, well, like, I'll try to shorten it due to time constraints. When we talk about speech as a modularity, allows users to communicate with machines using voice commands and natural language. It emulates the way we communicate with other humans, enabling a more fluid and controversial interaction with technology. Speech recognition technology has significantly advanced, making it more accurate and reliable, thereby enhancing the visibility and effectiveness of speech-based multimodal interface. Speech is a powerful modularity that enables users to communicate with machines using voice command and natural language, closely mimicking the way we interact with other humans. It brings a sense of familiarity and ease to human-machine interaction, allowing for more fluid and controversial experience. Advancement in speech recognition, technology have actually played a pivotal role in enhancing the visibility and effectiveness of speech-based multimodal interface. Speech recognition system can accurately transcribe spoken words into written text, enabling machines to understand and process human languages. This technology has witnessed significant progress over the years, with improvement in accuracy, speed, and adaptability. Okay, that's in the speech arena. But when we talk, like another really important auditory is the touch-based interface. Now, the touch-based interface have revolutionized the way we interact with machines by bringing a tangible and a tactical dimension to human-machine interaction. With the widespread adoption of touchscreen devices such as smartphones, tablets, and interactive displays, users have become acclimated to directly manipulating objects on a display, mirroring our interaction with physical objects in the real world. The introduction of touch-based interface has greatly enhanced the overall user experience by providing a sense of control instead of relying solely on indirect input devices like keyboards or mics. Or user can now use their fingers to interact with the graphical elements on screen. This direct interaction fosters a more intuitive experience, bridging the gap between the digital and the physical world. One of the key, let me just say this, one of the key advantages of the touch-based interface is the ability to perform natural gestures that we intuitively understand. Swiping, tapping, pinching, and rotating are just a few examples of the gesture that have become second nature to us. These gestures allow users to manipulate objects, navigate through content, zoom in or out, and perform various actions with ease. Gesture represents a powerful. So gestures are another method that how human human-machine interaction has progressed. Gesture represents a powerful modularity that enables users to interact with machines through hand and body movement, mirroring a natural way we use gestures to convey meaning and express ourselves in everyday communication. Multimodal interface that incorporates gesture recognition technology have the ability to capture these natural movements, allowing users to manipulate virtual objects, navigate interface, and perform actions in a more intuitive and expressive manner. One of the key advantages of gesture is their ability to leverage our existing repertoire or physical movement. From young age, we learn to communicate and convey meaning through gestures, such as pointing, waving, thumb up. By incorporating gesture recognition into multimodal interface, we can tap into this human ability to interact with the machines in a more natural and intuitive way. Gesture recognition technology analyzes the movement of the user hands, fingers, body, or even facial expression to interpret and understand the intended action. Through sophisticated algorithms and machine learning techniques, these systems can recognize the difference between various gestures, enabling precise and context-aware interaction. Again, an example would be virtual reality, but let's move to the haptic. The modularity of touch feedback introduces an additional layer of realism to the user experience in human-machine interaction by utilizing force, vibration, or tactical sensational. Haptic interface have the capability to simulate physical interaction and provide user with a sense of touch, enhancing their engagement and understanding of virtual environment. This technology finds particular in gaming, virtual reality, and augmented reality application. One of the primary advantage of haptics is the ability to create more realistic and engaging experience by incorporating the sense of touch in gaming. Haptic feedback can be employed to provide user with a tactical response in a game action, such as feeling the recoil of a virtual gun or the rumble of a racing car. These tactical sensational enhance the realism of gameplay, allowing users to feel connected to the virtual world and making the experience more dynamic and more interactive. User-centric approach by harnessing the power of speech, touch, gesture, and haptic, and placing the user at the center of the design process, we have the potential to revolutionize the way humans interact with machines. Multimodal interfaces offer a significant departure from traditional interfaces by providing more natural and intuitive means of communication. The combination of multiple modalists enables us to bridge the gap between humans and machine, as we mentioned earlier, creating more efficient, enjoyable user experience. Speech recognition technology allows users to communicate with machines using voice commands and natural language, emulating the way we interact with other humans. This enables fluid and controversial interaction, making the experience more intuitive and engaging. Touch-based interface with their direct manipulation of and on-screen objects provide a tangible and a dimension to human-machine interaction. User can interact with the graphical elements using familiar gesture like swapping, tapping, and pinching, enhancing the overall user experience. The immediacy and multi-touch capabilities of touch-based interface further contribute to the effectiveness and intuitive nature. Gesture leverages our natural inclination to use hand and body movements to convey meaning and express ourselves. By incorporating gestures recognition technology, user can manipulate virtual objects, navigate interface, and perform action in a more intuitive and expressive manner. Gestures provide an alternative means of interaction, particularly in scenarios where touch or speech inputs may not be visible or preferred. Lastly, haptics through touch feedback adds an extra layer of realism to the user experience by simulating physical interaction using forces, vibration, sensation. Haptic interacts enhance the perception of touch and creates a more engaging and likely interaction. Haptic find particular you can find it ultimately or obviously or utilities in gaming, virtual realities, and augmented realities application, where a user can feel the impact of virtual objects and receive feedback that enhances the engagement and understanding. By adopting a user-centric approach, we recognize that the design of multimodal interface should revolve around the needs, preferences, and behavior of the users. Placing the user at the center of a design process ensures that the interface are intuitive, efficient, and aligned with human capabilities. It allows users to leverage their existing skills and behavior, making the transition to new technology seamlessly and empowering individuals to interact with the machine in a way that are natural and transformative. As technology, as we all know, technology continues to advance, multimodal interface will play a pivotal role in shaping the future of human-machine interaction. The integration of these modalities seamlessly and cohesively holds and promise of unlocking the full potential of technology. By embracing a user-centric approach, we can create interfaces that not only meet the functional requirement, but also deliver delightful and meaningful experience. This empowers individuals to interact with machine in a way that are natural, intuitive, and transformative, enhancing productivity, enabling new possibilities, and improving the overall quality of human-machine interaction. Allow me to jump into the advantages and disadvantages of such a model. Some of the advantages of a user-centric approach would be natural interaction. We all know this natural interaction. By incorporating multiple modalities, a user-centric multimodal interface can mimic real-world interaction patterns, making interaction more intuitive and natural for users. This can reduce the learning curve associated with traditional interface and improve overall user satisfaction. Again, accessibility. Multimodal interface have the potential to improve accessibility for users with disabilities by providing alternative input and output modalities. Individual with visual or motor impairments can interact with machines more effectively, ensuring equal access to technology. Robustness. A multimodal interface can be more robust to variation in user preferences, abilities, and environmental condition. By offering multiple interaction options, user can choose the modularity that suits their preference or adapt to change contextual factors such as noise level or physical constraints. One more advantage of a user-centric approach, obviously, is the flexibility. Multimodal interface provides flexibility in how user interacts with the machines, depending on the task at hand or personal preferences. User can switch between different modules or use combination of modules to achieve their goals. This flexibility allows for personalized and adaptable interaction. That was some of the advantages of a user-centric approach. But let's talk a little bit about the challenges and consideration. Well, the most important challenge that faces us as humans when we interact with the machine or creating a model that interacts effectively with the machine is the design complexity. Well, designing multimodal interfaces involves addressing the complexity of integrating multiple modalities. Each modularity has its own design consideration and technical requirement. Designers need to carefully consider the interaction flow, mapping, and modalities to specific tasks and the overall user experience. They should aim to create a cohesive interface that allows users to switch between modularities effortlessly and provides a consistent and intuitive interaction pattern. Another challenge is the context awareness. To enhance user experience, multimodal interface should be context aware. They need to consider various contextual factors such as the user location, surrounding environment, user preference, and the task being performed. For example, in a noisy environment, the system should adapt by prioritizing speech inputs or providing visual cues. Context awareness enables the system to deliver appropriate feedback and response, enhancing the effectiveness and the effectiveness of the interaction. One last major challenge that we need to consider is the error handling. Handling errors or ambiguity in a multimodal input can be challenging. When users interact with the system through multiple modularities, they may be cases where the system receives conflicting or ambiguous input. The interface should be designed to resolve such conflicts, intelligently and provide meaningful feedback to the user. For instance, if a gesture is misinterpreted, the system should offer alternative options or clarify the intended action. User training and familiarity is another challenge that faces us. Obviously, by introducing multimodal interfaces, we will require users to learn new interaction techniques or adapt to unfamiliar modalities. It is essential to provide adequate training and guidance to users to ensure they understand how to effectively utilize the various models available. User interface should be designed to be intuitive and provide clear instructions to facilitate user learning and adoption. Last challenge, and I do consider it as one of the important challenges that faces us, is privacy and security. Now, when we talk about privacy and security and relate it to what we're talking about, human-machine interaction, multimodal interface often involves collecting and processing sensitive user data, such as voice recordings or biometric information. Privacy and security consideration becomes crucial in these scenarios. System designers must implement robust security measures to protect user data and ensure user consent and transparency regarding data collection and usage. Other challenges, I do believe, ethical consideration and scalability and compatibility. This leads me to the conclusion of my presentation today. In conclusion, adopting a user-centric approach in enhancing human-machine interaction through multimodal interfaces bring numerous advantages such as natural interaction, accessibility, robustness, and flexibility. However, it is also presents challenges related to design complexity, context awareness, error handling, user training, privacy, ethics, and scalability. Addressing these challenges will contribute to the development of effective and user-friendly multimodal interface that enhances the overall human-machine interaction experience. By this, that leads us to the end of our presentation. I will add my contact details for any question or for any question or any queries that comes to you, and I'll be more than happy to answer them. Thank you so much for giving me the time to share, to present. Hope you enjoyed it and hope it will be beneficial. Thank you so much. Good night.